All right, so practice test 10. I want to thank everybody for making it back today. We did, right? So here we go. Practice test 3, number 10. We're finishing this up because we have a big test tomorrow. Speaking of which, if anybody's doing the extended time route, I was supposed to have those papers by now. Oh, also, did we talk about serial route? We did, didn't we?
No.
All right, let me talk about it real quick. This starts next Monday. So Monday through Thursday, you have 4 possible days to bring in your cereal. You bring in 1 box for 1 point, 2 boxes for 2 points, and that's it. I mean, you can bring in 3 boxes, or 4, or 5, or 20, but it's still just 2 points. 2 points is the max. These need to be full size, like family size boxes of cereal, and they need to be cereal that you would eat yourself. It's for a homeless shelter for families, and so bring in cereal that your family would eat, not some weird random thing. It has to be unopened, and it has to be boxes, not bags. Okay, they have to store these things, and bags get crushed. So boxes, full size, any kind of cereal that you would eat. Okay, full size boxes. More.
Is this next week?
Next week, Monday through Thursday.
If you bring one of those like ones that have like 2 in them,
Yes,
that
counts as 2 boxes. Yep. Now, when you bring the boxes in, you bring them to me. Take them to your math teacher. That would be me. And I need to see that. I need to see you bringing them in. So don't like I just ran out for a few minutes. Don't bring them in and put them down, and then tell me later on, oh, Mrs. Ford, I brought in cereal. No, it doesn't count unless I see you bring in the cereal, because then I just put it in the grade book right there. All right, we'll make a pile over there, but I got to see you. If you send it with a friend, I'm fine with that, but make sure your friend tells me these are Trey's boxes. Okay? I got to see it. Bring them to me before school, during class, before class. Don't bring them to me at flex because I'm in the atrium, unless it's a short flex. Long flexes, I'm in the atrium, and I'm not carrying your boxes of cereal for you. Okay? Should be pretty easy, and it's a really good cause, and it's spearheaded by your fellow seniors. There's 3 senior boys that are kind of taking charge of this. All right, so here we go. Calculator problem. This is number 10A. Now, these are very much like the word problems. The only difference is in the word problems, you have to draw your own triangle. Here, it's already drawn for you. Once it's drawn, remember in the word problems what you have to do? You have to write an equation. You've got to write an equation for this. And every equation you write will either be a sine, cosine, or a tangent equation. So you look at the setup you've got, and you say, oh, that would be a sine, cosine, tangent. Which one?
Oh, no. Sine.
Sine. I heard somebody thinking out loud saying opposite hypotenuse. What function has opposite and hypotenuse? Sine. The angle is attached to the function. So it's sine 37 equals opposite over hypotenuse. This is an easy one. All you have to do is move the 12 over. So we move the 12 over. Uh-oh. Make sure your calculator is set in degrees. Make that change. Set in degrees. And then 12 sine 37. X is 7.22. Any question, Jonathan? You paying attention?
Yes.
Okay. Lunch makes us sleepy sometimes.
Boy, you ain't never lied.
I know. That's the absolute truth. I do know. I don't always tell everything, but what I say is true. All right, here we go. What function? Take a look at the scenario. What do we got here? It's another sine problem because it's opposite and hypotenuse. But the angle this time is x, which means I will do my special sign button. equals special sign. So second sign, 18/19. I got 71.33 degrees. If you didn't, speak up, please. Everybody good? All right, next draw a course of 204 degrees. Now, this is the time when your labels are a little bit different. When I'm doing regular math, the entire rest of the test, when I'm doing the whole rest of the test, my labels are these. And I don't want you ever to forget that. Those are your labels when you're doing the whole rest of the test. Okay? But this one's different because it's a compass. So in a compass, they're labeled like this. So when it says a course of 204 degrees, you are using these labels. So it would be down here. This is 204 degrees. And all you have to do is draw it. You don't have to do anything else, just draw it. Number 12. We do this one two different ways. We do this one without the calculator and with the calculator. Okay, so we'll start without the calculator. And like everything else you've ever done in math, you start with the parentheses first. We always start with the parentheses, right? So this tells me that my picture will be up here. See, there's that notation. That's the notation that tells me I'm up here or I'm over here. It's a positive 2/5, so I'm going to be over here. And I labeled that 2 and that 5 Y. Adjacent over hypotenuse. Now I need that third side. A squared plus B squared equals C squared. Now some of you are still not getting the Pythagorean theorem right. The one that's over here by itself is always the hypotenuse. So 4 plus B squared equals 25. So B squared equals 21. So it's
21.
root 21, which does not simplify or break down. It's just root 21. Now, what do I want to know about that? I want to know the tangent. That's easy. Opposite over adjacent would be root 21 over 2.
Is that your exact?
It's my exact answer. That's the exact answer. So now I'm going to get the decimal. I go to my calculator and I type in exactly what it looks like. Tangent, second cosine, 2 divided by 5. And you should have gotten 2.2913. Everybody get that? Alrighty. Now what have we got? All of our word problems.
Bruh.
Now, we have done so many of these, you know, all the other practice tests and, you know, practice and notes and everything. Every time there's a right triangle, right?
Bruh.
Every time. So I'll do problem A here and problem B here. You know there's going to be some kind of a right triangle in every one of these problems. So in A, we got a squirrel sitting up here in the top of the tree. The tree is 64.5 feet tall. So, see where I put the 64.5? Is that right?
Mhm.
The squirrel is looking at a nut on the ground. So here he is looking down at the nut on the ground. His angle of depression is 27 degrees. Where are we putting our angles every time? Right there. Somebody said at the top, and I'm coming back to hit you. They do not go at the top. If you put them at the top, they must be out here. And that is silly because it's not even in the triangle. Every angle of depression or elevation goes right here. Find the distance from the squirrel to the nut. So where does the X go? Hypotenuse. Now it's just like the ones we did a couple minutes ago. Take a look, I'm gonna write an equation. The equation is gonna be sine, cosine, or tangent. Which is it? Sine. This one's a little harder. It's sine 27 equals 64.5 over x. So the first thing we do is move the x over. And then we divide by sine 27. Remember, the angle always goes with the sine, or the cosine, whatever it is. The angle always stays with it. So 64.5 divided by sine 27. I got 142.07 feet. Don't forget to put a unit on that. How far is the squirrel from the nut? 142 feet. Directions tell me to round to the nearest hundredth, so that's what I did. Good? Number 2. A pelican on the top of a lighthouse. So here's our pelican on the top of our lighthouse. Spots a crab in the water below. The pelican is 93 feet above sea level. Is that 93 there? Make sense to you? He's 93 feet up in the air. The pelican is 202 feet from the crab. Hypotenuse, 202. Find the angle of depression from the pelican to the crab. Where are we putting that? Right here. Now, it's an angle. So when I get around to my calculator, it's going to be special. I need to write the equation first. What's the equation? Which function? Sine, cosine, or tangent?
Sine.
Sine. So sine x
Right.
equals 93 over 202. Guys, the angle always goes with the sine. So it's sine x. To get x, I need my special sine button. So I will second sine 93 over 202. So second sine 93 divided by 202, and I get 27.41 degrees. Everybody okay with that one? All right, well, I know they're all going to have a right triangle, so I'll go ahead and draw my right triangle. Let's see what we've got here for this next one. So here's C, and here's going to be D. All right, here we go. An airplane is currently 4,500 feet above the ground. Here's the plane, 4,500 feet above the ground. The pilot's angle of depression to the airport. So the pilot's looking down at the airport down here. And his angle of depression is 16.3. How far is the airport from the point on the ground directly beneath the plane? So where do I put the X? On the bottom. Because the problem clearly says, how far is the airport from the point on the ground beneath the airplane? All right, what function? So tan 16.3 equals opposite over adjacent. So this is another one where you have to move the x first. Right? And then divide. So I end up with x equal to 4,500 over tan 16.3. I got 15388.80 feet. Anybody match that since I made some mistakes today? You good? All right, 2 more and this test is done. Here we go. Find the length of the shadow. Find the length of the shadow of a 19-foot flagpole when the angle of elevation is 59 degrees. So the pole is 19 feet tall, the angle is 59, where does the x go? Find the length of the shadow. On the bottom. Groupies, where are shadows? Shadows are on the ground, right? That's where we see shadows. There it is, right there. Another tangent problem, that's right, today, tan 59 equals 19 over x, just like this one. So we're going to have x tan 59 equals 19. So x equals 19 over tan 59. You okay with that? So let's type it in, see what we get. No, 19 divided by tan 59. I got 11.42, and that would be feet. And finally, here we go. What is the angle of elevation of a pre-cal student looking at the top of a building that is 51 feet tall? Here's the building, 51 feet tall. Here's the kid looking up at the top of the building. The kid is standing 200 feet from the building. Now be careful, he's standing 200 feet from the building.
Bottom.
Here's the kid standing right here. Here's the building.
Oh wait, you said from base of the building.
Yeah, well,
Okay.
it says from the building.
Oh.
So if I said, how far are you away from me? Wouldn't you measure that on the ground? Now, if I said, how far is he from the bird on top of the building? That would be this. But it says, how far is he from the building itself? That's here. Where'd that 200 come from? Oh yeah, that is, he's standing 200 feet from it. What am I looking for? The angle. What's my equation? Well, it's tan x equals 51 over 200. But what I have to type in is second tangent, 51 over 200, because my x is my angle. And that's how I handle my angle. So second tangent, 51 divided by 200. I got 14.31 degrees. Remember, angles are degrees, not feet.
But if the question was like, how far is he standing from the top of the building, that would have been
Yeah. Now, that will never be the question, but the question might be, how far is he how far is he from a bird on top of the building? Okay? All right. Now, is there anything, I found an old quiz I thought we could do if we had time. But is there anything that you arc. Daisy. I'm missing.
Ready for English art?
I'm missing Eric again.
No, that's what she said. I was thinking about it.
Alright, so does anybody have something you particularly want to look at? Emily?
The arc length, like finding the measure of the arc.
Okay, you can do that. We know that's going to be a test question because it's on every single practice test.
Every
So
single one.
you know it's going to be a test question. So the question says, find the length of the arc, which is this right here. Find the length of the arc if the radius is 10 inches and the central angle is 80 degrees. Find the length of the arc. Alright, well, what pops into our head first is arc length equals radius times radians. So to answer this question, you need this number and you need this number. We have the radius. What? Radius, not radius. It's radius times radians. We have the radius. It's 10. But all we have is a degree, not a radian. So over to the side, pi over 180 equals x over 80. So 80 pi equals 180x. So x equals 80 pi over 180. So we can take out the zeros. So now we have 8 pi over 18. We can take out a 2. And that's it. So that is the number that goes here. So now we have to multiply 10 over 9 times 4 pi over 9. So we get 40 pi over 9, and that would be inches, just like the radius. If the radius is centimeters, that would be centimeters. That's your answer. That's the final answer. Everybody okay with that? Can you think of anything else that you think might be hard for you tomorrow?
The value of the 6 trig functions.
You're given one of them, and you have
What was greater than what?
you're given one function, so it might say something like tangent x is 3/4, and x is between 180 and 270, and then find everything else. So find sine, cosine, tangent, cosecant, secant, and cotangent. Now, this problem, guys, you better get 2 of these right without doing anything. They tell you the tangent is 3/4, which means the cotangent is 4/4. You cannot mess that up. I mean, it's given to you. Now, to find all the rest of them, we're going to do what we do in every problem. Draw a picture. So what is our picture going to look like? Well, it's going to be a triangle. And where is it going to be? Quadrant 3. Because quadrant 3 is between 180 and 270. This tells you where to draw it. Now the tangent is 3/4. They're both negative because of where we are. Then we'll do our Pythagorean theorem. So 3 squared plus 4 squared equals c squared. Remember, c is always the hypotenuse. No negatives in the Pythagorean theorem because you're squaring them out. So it's 9 plus 16. So c must be 5. And then I look back over here, okay, what sine opposite over hypotenuse? Negative 3/5. Cosecant, negative 5/3. What's cosine? Negative 4/5. Secant, negative 5/5. Anybody think of anything else that's gonna stress us out tomorrow? There's a lot of material, but I feel like we've practiced it so much that we have gotta be good at it. Alright, well, let me just, get a couple more minutes, let me just throw a couple problems at you. Now, these are old quiz questions. What does your test look like?
That's a good question.
Just like the practice test. So here's a question on this quiz. X over R, what function is that?
10, yeah.
Cosine.
Cosine, that's the cosine. X over R is the cosine. Pi over 6 is how many degrees?
30.
30, very good. You didn't even think about that one. Awesome. In this triangle, these are just random quiz questions. Which side is the adjacent side? A, B, or C? Which is the adjacent? B. Find the exact value, this is on the test. Find the exact value of the cosine of pi over 3. Alright, we're going to find the value of the cosine of pi over 3. So what do we do?
180 divided by 3.
It's 60. 180 divided by 3. Okay, then what? Wouldn't it be right here?
Yeah.
And this is 60. This is
Root 3.
1, 2. Anything negative?
No.
No, we're in quadrant 1. We want the cosine. What's the cosine? 1/2. Very good. Let's see what else we got. One more, and then I will just shut up. Because you are ready. Test tomorrow. Cosine 3 pi over 2. Here we go. Robbie, pay attention. Cosine 3 pi over 2. That's 270. Oh no, 270.
Oh, he's right on the line.
270.
0, 1.
I'm down here.
0, -1.
0, -1. That point is 0, -1. So x is 0. Don't get going too fast. X is 0. Y is -1. And R is 1. Now we need the cosine. X over R. X over R would be 0 over 1, which is 0. Awesome. All right, test tomorrow. Chris, can you hit that button?